Hey everybody, I hope you're ready for a crash course in trigonometry. It's time for math with Mr. Troy. All right, so for starters, just two problems for you to try. Go ahead, pause the video and see how much you remember from your geometry class. Hopefully you pause the video. I'm going to move on and give you the answers right now. Hey, I'm over here now. All right, here are our answers to problem number 1. You can go ahead and pause if we need to take a look at this in more depth. And here are the answers to problem number 2. Ask yourself as you're doing this problem if you understood what we meant by height and the length of the rope. Those are common sources of misconception. All right, time to move on to some new material. Hopefully whatever trigonometry class you took most recently, whether that was a geometry or a math 2, you talked about at least SOHCAHTOA, the 3 main trigonometric functions, and hopefully you were introduced to the cosecant, the secant, and the cotangent. So the 3 possibly new ratios are the cosecant, which is the reciprocal of the sine, the secant, which is the reciprocal of the cosine, and the cotangent, which is the reciprocal of the tangent. Now, one thing that I find useful for remembering the pairs is that each pair has a c in it. So the cosecant and sine has one that starts with c and one that doesn't. The secant and the cosine has one that starts with c and one that doesn't. And the cotangent and the tangent have one that starts with c and one that doesn't. The benefit of using the cosecant, the secant, and the cotangent is that maybe you want the opposite or reciprocal ratio. So maybe instead of having the hypotenuse in the denominator, you'd like to have the hypotenuse in the numerator. Let's take a quick look at a problem using this. All right, so quick problem for you. The cosecant of an angle in a right triangle is 0.75. What is the tangent of that angle? So I'm going to start by picking an angle. And I don't think this is going to be drawn to scale, but I'm just going to pick one of the acute angles. Now, the cosecant is the ratio between the hypotenuse and the opposite. So for starters, the hypotenuse over the opposite equals 0.75. Well, this doesn't make any sense because the hypotenuse has to be the biggest side in the triangle. So the hypotenuse over the opposite would have to be something that's bigger than 1. So this situation is impossible. Let's take a look at another quick example. All right, the secant of an angle in a right triangle is 1.8. What is the cotangent? So this time I'm going to be more careful. I am going to label the angle that is labeled as angle with theta. A lot of times when we're using trigonometry, we will use this Greek letter theta. The secant of an angle in a right triangle is 1.8. What is the cotangent of that angle? Okay, the secant is the hypotenuse over the adjacent. And that is 1.8. Well, 1.8 as a ratio is either 1.8 over 1 or, I believe, 9 over 5. So I could use either of these, but I'm going to use 9 over 5 because I think I would just rather use natural numbers. So I'm going to label the hypotenuse as 9 and the adjacent as 5. Now it asks me what the cotangent is. So the cotangent, which is abbreviated COT, this was the secant of theta. So the cotangent of theta is going to be the adjacent over the opposite. Now, I'm not told what the opposite is, but I am in a right triangle. So I know that this relationship has to be true, that the opposite squared plus 5 squared has to equal 9 squared. Or the opposite squared plus 25 equals 81. Or the opposite squared equals 56. So this means that the opposite is the square root of 56, and that would reduce to 2 root 14. So my opposite is going to be 2 root 14. So that would make my cotangent 5 over 2 root 14, which of course I have to rationalize. And I'm going to get 5 root 14 over 28. Notice that we had to go to the Pythagorean theorem, which we are allowed to do because we have a right triangle. So here is one for you to try. Find all 6 trig functions for that angle theta. We have an adjacent side of 7 and a hypotenuse of 9. We do not know the opposite side. So pause the video and I'll put answers up when you're ready to unpause. Okay, so the first thing that I did was I found that angle was 4 root 2. Sorry, not that angle, that opposite side. And that allowed me to find the sine and the tangent. I didn't actually need that for the cosine. Now, when I find the reciprocal functions for the sine and the tangent, that's going to put that radical in the denominator, and you will need to multiply by root 2 over root 2 in order to simplify. Give that a try. All right, here are the 3 answers that I got for the cosecant, the secant, and the cotangent. Now, once I found the reciprocal, just by flipping the fraction, I then did have to multiply by root 2 over root 2 in order to rationalize my denominator. So that's how I came up with that answer. All right, folks, thank you for your attention. We are in the home stretch. We've got a little bit of new vocab here. It says, let the point 3, 4, so that's just the regular point 3, 1, 2, 3, 4, be a point on the terminal side of an angle in standard position. So the new vocab for you here is that an angle in standard position is an angle that starts off on the positive x-axis. So that's where its first ray is. And then it opens upwards or counterclockwise. The terminal side is the line where the angle stops, and the initial side is the line where the angle starts, or I suppose I should say the ray. So we think of the angle as opening up like this. Now, they want us to find the 6 trigonometric functions of that angle. So the first thing I want to do is I want to get that little angle marker out of the way, and I want to draw what's called a reference triangle. That triangle allows me to look at this angle as having an opposite, an adjacent, and a hypotenuse. Now, the other thing that's cool is because this is on a coordinate grid, if this is the point 3, 4, that means that I have 3 as my adjacent and 4 as my opposite. And by the Pythagorean theorem, I have 5 as my hypotenuse, which makes it really easy to find the sine, 4/5, and the cosecant, 5/4, the cosine, 3/5, and the secant, 5/3, and the tangent, 4/3, and the cotangent, 3/4. One thing that's worth noting is that this would be true whether I was talking about the point 3, 4 or I was talking about the point 6, 8. Those would be similar triangles, but the ratios would reduce down to the same thing. Another thing to think about is, though, while I'm thinking of this as a ratio of 4 to 5, it's also 0.8, because that is what that ratio reduces to. One thing you need to memorize, or know, or understand is what an angle in each quadrant would have as its sign: a positive, a negative, or there are certain places where the sign can be 0. What would it have as its cosine? A positive, a negative, or there are places where the cosine could be 0. How about its tangent? A positive, a negative, 0, maybe be undefined. So we have a way of remembering this, and is this acronym or mnemonic device: all students take calculus. In the first quadrant, all of the trig ratios are positive. In the second quadrant, the sign is positive. So the reason for that is if you draw an angle and you draw your little reference triangle, the x value would be something negative, while the y value would be something positive. So I'm just going to use those numbers from the previous problem. The opposite over the hypotenuse would be positive, but the adjacent over the hypotenuse would be negative. So first quadrant, everything is positive. Second quadrant, the sign is positive. Third quadrant, the tangent is positive, and the fourth quadrant, the cosine is positive. So that's just a way of memorizing in the different quadrants which are positive and negative. And finally, our special right triangles. The relationships in a 45, 45, 90 triangle are that the legs are equal to each other, and the hypotenuse is equal to one of the legs times the square root of 2. In a 30, 60, 90 triangle, one of the legs is half of the hypotenuse, and if you multiply that leg by the square root of 3, you get the longer leg. So those are our special right triangles. All right, folks, I hope that was helpful. Enjoy watching, watch again, tell your friends, like, share, subscribe. Remember to ring that bell. Okay, have a good one, everybody.